McKinsey's AI platform, Lilli, 700,000 files, 57,000 user accounts, 46 plus million chat messages, all of it accessible without any authentication prompt in 2 hours. Chris, what actually happened?
Well, this was a fundamental architecture failure. The attackers didn't hack a firewall. They simply asked for an overprivileged AI the right questions, and AI politely handed over the keys to the kingdom.
So this is not a break-in. It's really, I just logged in.
Yeah, exactly. It used legitimate credentials to do illegitimate things. That reality breaks traditional cybersecurity. So in the agentic era, trusting an identity is no longer enough. You have to mathematically restrict the execution.
Now, for me as a global fintech thought leader, this is really important. McKinsey is a consulting firm. Everybody knows how important this firm is. Recently, they joined the Frontier Alliance with OpenAI so they can help the business world adopt and integrate AI and become AI native businesses. For me, this incident is, wait a minute, banks are adopting this. How can we think about this? This is really a very important cross-industry topic that we need to discuss. Let me first introduce you, Chris, before we deep dive into this fascinating discussion. Everything is interconnected today. This really touches on financial services and what is happening. For our guest, Chris Biel is not a traditional cybersecurity persona. He has been actually he's been involved in Web3, really building, co-founding for the last more than 5 years, I believe. You are a contributor to the Bankless DAO. You have co-founded the Bankless Card. You are working with the Open Matter Network. And online, your name is an interesting pick, NFT thinker, which I assume is associated with sort of what is the digital identity? How can we cryptographically do things? Are NFTs as a solution? Thank you for joining us, Chris.
So much for having me, Effie, and thanks for your invitation today. Yeah, it's actually NF thinker, as in non-fungible thinker. I did join Bankless DAO at the beginning, actually. I was a Genesis member of Bankless DAO. DAOs at the time were extremely popular after the Uniswap airdrop that happened. Everyone was extremely excited about digital ownership, NFTs being one of those things. And I come from a media background. I'm a photographer by trade. I have been for many years. And I'm very concerned with digital rights and digital ownership, because obviously when your content...
Intellectual property type.
Exactly. When your content is released into the wild, how do you track its usage and how do you pass ownership or value back to the creator? And I was listening to an interview of Elon Musk talking about Neuralink, where he discusses the capabilities of reading people's thoughts, which are essentially then transmitted to the cloud. So they're accessing your core thoughts, passing those to the cloud. I don't know the exact functionality around that now, but where I see that going in the future is our thoughts then become part of this hive mind, which enables a lot, but it also takes a lot from us. So how do we have non-fungible thoughts? How do we have ownership around the things that happen in our mind that we maybe do or don't want to release to the wild? So that's the genesis of my name, my actual name, Chris Biel. And as you mentioned, the DAO space, I became very active in the DAO space towards the tail end of the pandemic. And there was so much exciting stuff happening there around governance, tokenization of real world assets, of digital assets, the creative space. As I mentioned, coming into this from a creative background, I didn't really know where I fit in. So I started working with the Design Guild and putting people together in different projects. Somebody needed a web designer, somebody needed a graphics designer, somebody wanted drawings or cartoons done to better describe their concept. So I was coordinating a lot of those efforts within Bankless DAO, and it led me to work with so many different projects in the investment space, in the art space, and in the event space. I was going to different cryptocurrency events around the world, and I started doing media for Bankless DAO. I was hosting a lot of AMAs, and I hosted a full series on privacy within crypto. That was my first real introduction to private transactions, MPC, zero knowledge. I spoke with NIM VPN and Zero and Near and a bunch of different projects who are really pushing the boundaries of privacy. After Bankless DAO, I went on and did some spaces with Shapeshift for a while, and that sort of led me to where I am today with my job at Open Matter Network.
Yeah, interesting. And we connected on X because I put out a tweet when I found out about this McKinsey incident. And I admit, I mean, it went viral. It's got 500,000 views, comments, bookmarks. In my 10 years of tweeting fintech is not so broad. And this really hit a nerve. And it was your comment and insight that led me to connect with you and take a deep dive in understanding this for business people, because we are all around us. There's a lot of bidding or building going on to build the primitives, the stuff that are needed for an agentic era, starting mainly from agentic commerce, which is very much linked to finance and fintech because we need agentic payments. So before we go deeper in that overlap, let's unpack the incident of McKinsey, because most people read it in the media and it seemed like a traditional cybersecurity or data breach, but it's not. I know from your insights and from reading afterwards that what happened was this research firm called Codewell. Am I saying it correctly? Yeah, Codewell was doing a security audit and this unfolded. So tell us a little bit about what really happened.
So let me just preface this by restating what you already mentioned is I'm not a cybersecurity expert by any means. So if there are any cybersecurity experts out there listening right now, feel free to drop a comment and let us know where we're wrong on this. And also in terms of what we're building at Open Matter Network, how this connects and why I was so interested in this topic specifically is what we're trying to do is enforce agent behavior mathematically. So we use MPC and ZK circuits to do that. And our zero knowledge firewall lets enterprises safely deploy agents into private data silos with cryptographic circuit breakers. So that makes rogue execution and data exfiltration impossible. So these types of hacks won't happen in the future once our primitives are in place. And we're working with various different institutions to bring these into fruition and get them into the wild. One very important point there is that this will be a bring your own agent type of scenario. So the existing agents that are out there now will be able to access data silos without getting the information. They just get the insight. Therefore, there is no liability of releasing sensitive data. The core insight around this breach specifically is it was a fundamental flaw in how enterprise AI is built. In basic terms, standard AI systems use something called retrieval augmented generation, or RAG, and think of it as giving AI an open book test, but instead of handing it one relevant textbook, developers basically gave it the master key to the entire corporate library in plain text. And why the architecture matters is the hackers didn't need to exploit complex firewalls. They simply asked the right questions to an AI that had God mode access to 3.6 million unencrypted document chunks. And the architecture failed because it relied on trusting the AI's behavior rather than mathematically restricting its access.
The way I understand it, Chris, is that currently in these systems, like Lilli in McKinsey, you give different AIs permission but that permission is not like the permissions you give to human. If, let's say, I'm an entry-level financial analyst, I can't log in, for example, to the emails of the CEO of the bank. I can't log into the systems and execute a trade. I can log in and see the trade transactions. And I also have a human judgment that I'm not supposed to execute a transaction, a trade, or send an email on behalf of the CEO. I'm not going to do that. There's an audit, I'll log out. So find, whereas an agent doesn't have that judgment. And it seems, my understanding is that the current design, we are not able to limit the scope of the AI agent, of what they can do, because if we do that, then there's too many conditions that we can't even design. There isn't an autonomy. Is that correct, the way I'm seeing it?
And it is very similar to your human example, where agents are given strict boundaries, and just the same way a human could skirt those boundaries by, say, for example, you meet somebody within the company who has higher access to you, you take them out for dinner, you wine and dine them, you become their friend, you gain their trust.
Yes.
The key word here being trust. You gain their trust, and then you exploit that trust to gain higher access. Agents are doing the same thing, but at lightning speed. They don't have to take you out for dinner and wine and dine you. They just have to convince you that, oh, you can trust me. Why don't you give me access to this API? And then another agent will reveal its keys, and it's a sort of downward spiral from there.
Okay. And that happens agent to agent, obviously.
That happens agent to agent, yes.
This is not like a hacker. It's more like an insider incident, you would say, and it has to do with the problem of identity and the problem of an agent acting beyond its mandate.
Yes, yeah. So at the source point, there is a hacker who's trying to use an agent to gain trust of other agents. So at the core of it, at the heart of it, it's a hack, but on the inside, it is just agents talking to other agents saying, hey, trust me, bro. And they get more insights, or they get more access than they should be allowed.
Yeah. So if I think of JPMorgan, and I mention them because they are a huge player in financial services, they are recognized as leading in terms of AI adoption, and obviously they have something like what McKinsey has, Lilli, an internal assistant. They call them the LLM Suite. It's accessible, available to 200,000 plus employees. So I'm trying to think, if something like that could happen at JPMorgan, what's the blast radius? What could an agent get access to? Would it be transaction data? Would it be policies and regulations? What could it be?
Well, if they're using a similar system to what McKinsey had, RAG architecture, then certainly they're exposed. If they're using other architecture, that's to be determined. If it's a trust-based architecture, there are almost certainly ways to skirt that. And the blast radius is mergers and acquisitions, market abuse, algorithmic and trade data, regulatory and compliance issues. And the bottom line is that their entire institutional brain is exposed. If the underlying data isn't cryptographically sharded, like with open matter networks, data visor implementation, a single prompt injection compromises every silo simultaneously.
Okay. So it's even a business, and I'm always thinking of a bank that has gone through a digital transformation, and therefore there's all these internal APIs and external APIs, but mainly looking at the internal APIs. And now you have an architecture of an AI assistant. There's a lot of vulnerabilities, you're saying, And the current architecture that you mentioned that McKinsey is using, is that a common architecture? Are there many different architectures out there, to your knowledge?
I'm not totally sure. That kind of goes beyond
Yeah.
my knowledge of this area, but I do know that RAG is quite common, and it's because it's useful. It's quick, it's easy-ish to implement, and it allows certain guardrails to be put up. But again, those are trust-based mechanisms, and you really have to cryptographically secure these things.
So we are actually finding out from large production projects like the McKinsey one that there's vulnerabilities because agents are over permissioned because the guardrails there. And we really need to make sure that agents can't go beyond their mandate, which brings me to the world that I'm focused on. I look and I'm very interested on what is going on with agentic commerce and the infrastructure that's been built there. We have protocols like Google put out the UCP protocol for payment infrastructure, and now Mastercard and Visa are very excited about agentic commerce and have used different methods of verifying an agent. And apparently they work with some type of tokenization. They can verify the agent, but they can't really verify whether they're within their mandate, the status, if you want, of the market. What, from your perspective, what are the thoughts around what Mastercard and Visa are doing to have a mechanism to identify in a trustworthy way an agent? What do you think is good but is missing? What are you seeing in the market happening?
So in the first instance, they're utilizing tokenization, which is good because tokens are auditable and can be controlled through a variety of mechanisms. They're a good gating mechanism. They secure the payment, but they really do nothing to secure the agent's intent. So when you're looking at an agent's intent, that is, what does the agent want to do? And you give your intent to the agent. You say, I want you to research this data and return meaningful insights. And the agent can translate that intent and implement it in a way that allows it to return the insights. But by doing so, it may misinterpret, it may use nefarious means of getting that information, and it might be breaking the rails without you even knowing it. So some of the things that we're building right now are called zero knowledge circuits for agents. And there are a few different circuit implementations. We have output compliance, which represents an output, and forbidden policy as sorted field IDs. So that allows you to basically assure that the output is compliant with your intent. Okay, so the answer that you're receiving isn't something that you weren't allowed to receive. You have tool call compliance, which is essentially request sanitization. It represents the request as a key value metadata pair and represents sensitive keys as a sorted list. So the agent proves masking the values corresponding to the sensitive keys. It essentially means that you're not allowed to implement a tool call that isn't allowed. And then you have endpoint allow list, which allows you to prove that the request was a subset of an allow list via 2-pointer subset checks. And then finally, we have access controls. And those access controls are similar to what you can do with tokenization, but they're zero knowledge access controls. So using Merkle trees, and the agent can prove the verification of the Merkle tree paths. It starts to get quite technical, and we can break those down if that's something that you're interested in learning more about.
But what is the gist of this? Because I understand the first part, it's simple, that the output, that's like the first level, that the output is in alignment with the intent, with the mandate, right? But all the rest that you're mentioning that is quite technical are really going behind the scenes into kind of tracing the way the agent produced this output. Is that what is going on?
Yeah, in essence, it's a form of auditability. So you can allow your agents to access data, and then be that in the moment or a week later or a month later, you can always go back and assure that nothing was accessed that shouldn't have been accessed.
And is there also included a blocking mechanism if they go to access something that is not correct?
Yeah, they essentially act like circuit breakers. So if the agent is trying to do something it's not allowed to do, the task fails and no insights are given back.
So I guess this really helps with real-time monitoring for businesses to see what is happening, and maybe have a dashboard, a way of monitoring the circuit breakers, so you learn
Mhm.
what went wrong but was prevented, so to speak, and maybe adjust.
Yeah, in essence, you can see how agents are trying to skirt the rules,
Okay.
and you can see where they failed and why they failed and how they failed. That if you're deploying agents and it costs you $10,000 to deploy this agentic swarm to perform research, and it comes back with zero insights, you want to find out why it failed. So you can fix the issues in your agent, and you can also verify that nothing was leaked.
Yeah, so it works on different dimensions, adding value to what is needed. And the vision here is that these types of processes would be embedded in the governance, in the architecture of whatever's built. Or where are we in the market right now in terms of such solutions, be it the Open Matter Network solution or other similar solutions?
Yeah, so there are a number of different companies working on this at the moment, and our agentic implementation has actually sprung up from the current narrative that is just everywhere right now. Our core principles are on the cryptographic sharding of data that allows machine learning on a shard of encrypted data rather than the data itself. So that's what we were originally building. We've been building this for nearly a year now. And essentially, you take a data set and encrypt it, and then you break that into thirds and you upload 1/3 of that encryption to the network. The machine learning is done on the network side using the high power compute network, and then insights are returned and the circuit completes back on your client plane. Okay, so without your client plane, if you remove that from the circuit, anything that is retrieved from the network is just noise. There is no actual data from the client plane that accesses the network plane. So you really need that full circuit to complete in order for any verification of data. Now, as we were trying to sell this to organizations and speaking with different potential partners, every single one of them was coming back and saying, hey, can I use this with an agent? Can I deploy an agent to your network? Can my agents access your data silos? And basically the answer was, yes, we can build this for agents. So now we've been building like crazy, trying to get these agentic primitives out.
Okay.
And what it allows, as I mentioned before, is a zero knowledge firewall, right? That allows any external agent to come and query data that has been processed by our network. Okay, so if you have, say, for example, 4 pharmaceutical companies and they want to collaborate on biomarker research, they can encrypt their data, upload a shard to the network, which allows for processing of that data and real world insights, but none of the other companies will actually get the raw data. And that's important for IP, but most importantly, for from the consumer standpoint, it is, or the
Right.
public standpoint, it's important for HIPAA, GDPR,
Yeah.
basic PII data. You don't want your birth date, your name, your address
Sitting
out there in the
around.
wild.
Yeah.
Exactly. So any agent can then come, query the data, return the insights, and they're not getting any access to the original data silo.
Chris, as I listened to you, you gave this example, but my mind is like more financial services. This could be a use case for anti-money laundering data,
Yes.
KYC data shared with zero knowledge processes, and that would benefit all the participants in this network, not only better services, more secure, lowering the cost of these processes, and at the same time doing it in a secure way that they're not really sharing the actual.
Yes. Yeah, absolutely. For AML, it's extremely helpful because you mentioned JPMorgan. They don't want to share their client list with people outside of their organization, but they want to access insights and information from other banks, while those other banks also want to access that same information from JPMorgan. Together, it makes the entire industry stronger, and it makes us all more compliant without revealing our data and without revealing our personal information.
And especially nowadays that each of us, whether we're individuals or businesses, we have multiple banking providers. So the same person can be banking in more than one institutions.
Absolutely.
This is extremely important. Two questions before we close, Chris. One, if a financial regulator or a customer protection agency comes to you and says, okay, given all this that is going on right now, what are the questions that we should be asking as regulators to start designing policies to protect consumers and the industry from all this? And when I say from all this, what we were discussing around the architectural issue of these agentic in production assistants, because otherwise the topic is too broad.
Yeah, I think the biggest question is how do we move from trust based systems to cryptographic based systems? So, how do we make it hard for things to go wrong? How do we transition from being hard for things to go wrong to making them impossible for things to go wrong? And when you look at all the different trust mechanisms that are in place currently, they're all potentially open for flaw. Even when you look at TEEs, which are commonly used in securing data, trusted execution environments.
Okay.
So on your phone, for example, your iPhone, Apple was one of the first to market with these in a large scale when they implemented your thumbprint, which then became your Face ID. They store your data in a TEE, a trusted execution environment, which they also call a secure enclave. And that secure enclave it's impossible to hack. You can't, if you take the chip out of a phone, you can't hack into that and get any of the information out. But the fact that it is a trusted execution environment, the trust comes from the manufacturer. In this case, that manufacturer is not Apple. As far as I know, they're not building their own TEEs. They're getting their TEEs from a different chip manufacturer. And if that chip manufacturer has built in a backdoor, then that opens up every single TEE to data release. Yes.
Yeah.
So how do we move from trust to cryptographic?
To cryptographic. So are you saying that the TE is not cryptographically protected, or?
The TE is cryptographically protected, but the trust lies in the fact that we are trusting the manufacturer of that chip and trusting that they didn't build in a backdoor. Now, there is a lot of information going around right now talking about how the NSA has essentially forced Intel to build backdoors into all their TEEs. I don't have verification of this, but I've seen it mentioned multiple times. And whether or not the NSA has mandated that, it doesn't change the fact that it could be done if Intel had a rogue actor or if any of these intelligence agencies mandated it. then all of our trust is broken. Now, the scariest part about it is there's no way to verify it. If I want to verify that my TEE is not compromised, I essentially have to take the chip out of the device and deconstruct the chip, which essentially breaks it. So there's no way to verify that your TEE is secure. You have to trust that your TEE is secure.
And as you said, the word impossible needs to be the reality towards we need
Absolutely.
to build. And on that note, last question I want to ask you. We all know things are moving really fast. Every day is more intense than the day before. We all feel it. What are you excited about for the next, let's say, 12 months or 6 months? Where is your focus and your excitement in this market?
Yeah, I'm extremely excited for X402. We touched on that before with these payment primitives. The X402 architecture was released, I believe, last year, and it's a way for agents to transact online. It's a way for them to pay each other to get jobs done. You give them a budget, and they go out and complete a task with the money that they have available to them, and they don't need Visa or Mastercard specifically to create the payment rails. What I'm even more excited for is the products coming out around X402. So there are a lot of marketplaces that are making products and services available to agents. One of the really interesting, slightly scary, but extremely exciting implementations of agentic commerce is agents now being able to control robots so they can interact with robots. And it's scary because
with physical AI.
Yes, using DPIN to access the robotic network or the Internet of Things. And that will have real world implications. It's exciting because it means that we're moving one step closer to a robot doing things that you want it to do without you even telling it, based on an initial intent that you give your agent, your Mac Mini, or in our case, you can deploy your agent to Open Matter Network and you just say, okay, I want you to make my life easier in these different ways. Now that agent will have a budget and it will be able to pay a robot to make your coffee or wash your car or book your flight or
go pick up my laundry from the dry cleaners.
Yeah, and they can fold it now as well, apparently. So there are a lot of different implementations. So X402 is something I'm really excited about. I'm probably more excited about this is something we didn't actually touch on, which is extremely important to our thesis, which is post-quantum safety. So
I was going to ask you, because you spoke so much about cryptography, but I didn't want to lose the track. Is what you're building there also for quantum readiness?
Yes, yeah, we are post-quantum safe protocol based on lattice-based cryptography. And the threat in the future is that quantum computers will decrypt information that is encrypted with current encryption standards, and all of that data is released. The threat today is that all of our information that we're sending over the network in an encrypted state can and is being harvested. Maybe not all of our data is being harvested, but some of our data is being harvested by organizations like Lazarus and other hacker groups. They are gathering all this information and storing it in their data servers for the event, for the post-quantum event when everything is decrypted. Once that happens, anything that you have sent in an encrypted state, your passport, your financial documents, your personal information, your health information, your DNA sequencing, all of that information is instantly available. It becomes decrypted. And that is the term for that is harvest now, decrypt later. So you may have heard that term. So harvest now, decrypt later is a real concern. And what I'm excited for is ourselves and other companies that we're partnering with in collaboration with NIST, which is a standards body for encryption. And what we're building is protecting the user today for the exploits of tomorrow.
Interesting. And as I said earlier, everything is interconnected. So it is what we're doing in AI, and what we spoke about today is really at the convergence of AI and Web3 or cryptography. And it is clear that what we thought about what Bitcoin brought to the world after 2008 is really changing society. It's really changing the social contract. Basically, without trust, cryptography is at the core of that. We're redesigning it. It's exciting and scary times. Chris, thank you for joining us today.
Thank you so much, Effie.